All right, guys, today we're going to graph and write equations of circles. Starting 3 days here on conic sections. These are all pieces of cones. That's what I call conic sections. And today we're going to focus on circles, which is, the bottom of a cone. All right, a circle, definition, a set of all points in a plane that are equidistant from a fixed point called the center. So if you look at the picture down here, the red dot on thing, that's the center, obviously, of the circle. The distance, r, is called the radius. So when you see that point, that r right there, it's the radius, and you should know that from geometry. The basic equation of a circle is like this, and that's coming up here on the next slide. Here we go, the standard equation with the center at the origin. Okay, so everything we're going to do today, the center is going to be surrounded, is going to be at the origin. Center is 0, 0, radius is r, but look at the equation, it has an r squared. So when you see your equation, the number on the right-hand side will be the square of the radius. So to find the radius, you actually have to take the square root. Let me show you a couple examples here. All right, the first one says graph y squared equals negative x squared plus 36. Identify the radius of the circle. You're going to have to identify the radius to even graph it, so that should be pretty easy. So if you saw the standard form a second ago, you know we need x squared and y squared on the same side. So I'm going to move the x squared over. X squared plus y squared equals 36. Now, the center is 0, 0, and it's going to be that way all day tomorrow. And the reason is because there's nothing on this side except for the x squared and y squared. Remember the radius, this is r squared over here. That 36 represents r squared, so the radius is 6. So to graph it, there's my center, which is not actually part of the circle, but the radius 6 means I'm going to go 6 to the right, 6 up, 6 left, 6 down, and really all the way around. But I'm going to connect the dots with a circle. This will probably be a really bad one, but I'm trying. Okay, that's not very good, but there's your circle. So that's all you have to do. Pretty easy. All right, one more here. The point 2, negative 5 lies on the circle. Whose center is at the origin? Write the standard form. Okay, so here's what I know. I know it's x squared plus y squared, and I also know that over here is r squared, which is what I need to find. I'm trying to find r squared. Now, here's the key. Without making you do a whole bunch of work, this is a secret way to do this, so don't tell anybody I'm telling you, but you know this already. Why does that point lie on the circle? And the reason is because it works. So just plug it in. Just take that point and plug it in. Put the 2 in for the x. Put the negative 5 in for the y. And I'm just going to work out that side. Okay, so that's going to be a 4 there. That's going to be a 25, which is 29. Now, that equals r squared, which is what I needed. I needed my r squared, which is 29. Okay, so my equation circle, x squared plus y squared equals 29. Now, 29 is not the radius. The radius would be square root of 29. And you can see a lot of radii tomorrow that are square roots, because remember the other side is r squared. So you can have a lot of square roots for radii. So by the way, radii is plural of radius if you're wondering. And that's really all we're doing tomorrow. Okay, so don't forget this. That's a great trick right there. To be honest, they wanted you to do distance formula and all that kind of stuff, but it's just quicker just to plug them in, because you already know the reason why a point is on the figure is because it works. All right, so we'll work on it tomorrow. See you then.